right, so we're going to do a little bit more complicated problem where we add two expressions before we solve. So on the left, we don't have a common denominator here, so we have to multiply by the opposite to get a common denominator since they don't have anything in common. So over here we have 2n plus 2, and here we have n squared plus 2n, all over our now common denominator, which is n times n plus 1. If we put this into standard form, we get n squared plus 4n plus 2 over n times n plus 1. So that's our left side now simplified. And over here we have our right side, negative 2 over n squared plus n squared plus n, which is actually n times n plus 1. So what we can do is multiply n times n plus 1 to clear both denominators instead of cross multiplying. Now, if you want to cross multiply, you can do the same thing, but if we have two denominators that are equal, then we can just clear them and get rid of them. So now what we have is just the tops. So now we have just this equals this. So now that we have that, we have just a regular quadratic equation. So now we would add 2 to both sides, and we get n squared plus 4n plus 4 equals 0. And then we can factor this, n plus 2, n plus 2, which gives us a solution of n equals negative 2. That would be our final answer. The only thing is we have to go back and look at excluded values. So here our first expression, our excluded value would be n cannot equal 0. Our second original expression would be n cannot equal negative 1. And here we remember this is n times n plus 1. So that's the same thing. N cannot be 0 and n cannot be negative 1. Since that doesn't interfere with our final answer, this would be our final answer, n equals negative 2. And that means that's the only number that you could plug in here to get this to be a true equation. If you want to check your answer, you can plug it in. Plug it in for each n value, and you should get two equivalent expressions. All right, so for the second problem here, we're going to do one that does not have the same denominator. So this is 5 over 2x minus 2 equals 15 over x squared minus 1. So here we don't have any addition, so we can just go straight into cross multiplication. So when we do that, we have 5x squared minus 5 on the left equals 30x minus 30 on the right. And this is a quadratic equation, so we can move everything to one side. We get 5x squared minus 30x plus 25 equals 0. And here we have a GCF of 5, so we can take that out. We get x squared minus 6x plus 5. Now that's a nice, easy factorable equation. We have 5 times x minus 5, x minus 1. And so we get our final answer is x equals 5 or 1. Now we need to go back and check our excluded values. So from the beginning, this, if you factor, it would be 2x minus 1. So here x cannot be positive 1. And here this would be x minus 1, x plus 1. So here we got x cannot be 1 or negative 1. Now if you go back and look at our answer, we got 1 as our answer. But if we look back up here, 1 will make this an excluded value. So you have to cross that off, and your actual answer would be x equals just 5. All right, now there's one thing that I want to show you that some people make a mistake. If you did this problem and you factored this out into x minus 1, x plus 1, and this to x minus 1, it would still work the same way. So this would be 5 over 2 x minus 1 equals 15 over x minus 1, x plus 1. And when you do that, you could cross multiply and get 5x minus 1x plus 1 on the left, and on the right, 30 times x minus 1. Now, you might think, oh, right here I can just divide by x minus 1 and cancel that off on both sides. Now you can, but what you are doing is you're dividing out a solution. So since this is in the numerator, it's actually a solution. It's part of the factorable answer. So you cannot divide by a binomial because you're getting rid of a solution. Now when we look back, that one was an excluded value anyway. So in this case, it wouldn't have mattered, but I want you to do it this way so that you're not dividing out a solution. Make sure you get both solutions, then you can go back and look for the excluded value. So just a tip, instead of factoring on these, you want to go straight into cross multiplication and make sure you never divide by a binomial because you'd be dividing out an answer.